Hello everyone, my name is Aziz Tazri bin Faizli. So today, me and my fellow group mates, which is Muhammad Norizme, Muhammad Ammar and Wan Afif Amjad, will do our project proposal presentation regarding Dynamo lamp that use a time varying field application. So without further ado, I will pass the introduction to my friend.
Assalamualaikum. Hi, my name is Muhammad Ammar bin Mustafa Kamal. My ticket number DE2202129. I'm from Group 2, Section 2. So this is our group presentation video for the EMT subject. So moving on for the first introduction. Electromagnetic field and wave, we know that this subject or topic is crucial for human because this subject is used in many technology like wireless communication, imaging and energy harvesting. So for us, in order to visualize the thing that we learn in EMT subject, we have decided to explore the time varying field, and we decided to make a dynamo lamp. So this dynamo lamp is essentially take use Faraday's law, which is it convert mechanical energy into electrical energy. Then the electrical energy then is used to power a LED or a light bulb. So next, the existing application and the importance. So this dynamo lamp is important because in application that require a portable or off-grid lighting solution, such as emergency kit, um, outdoor activities and region with limited energy access, electricity access. So as I said, simply brief before, this dynamo lamp use the mechanical energy, usually from hand cranking or rotational motion, and convert it into electrical energy. It then use to power a LED or a light bulb. So this is the the dynamo lamp is crucial in a scenario where the sustainability is critical. So next, we move on to my next friends to present about our problem statement.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail bin Asmawi. And now I'm going to talk about background and problem definition. First, so now I'm going to talk about existing applications and importance. Dynamo lamps are widely used in emergency kits, outdoor activities, and regions with limited access to electricity. They are especially useful because they don't rely on external power sources. Instead, they operate on the principle of electromagnetic induction. By converting mechanical energy, like hand cranking, into electrical energy, they power light sources such as LED or incandescent bulb. However, while the concept is brilliant, current design comes with several issues that limit effectiveness. So for the problem statement, there are three main challenges that we have identified. The firstly, electromagnetic interference, EMI. The magnetic field generated by the lamps can interfere with the nearby electronic. These require improved shielding solutions. Secondly, low energy conversion efficiency. Many existing lamps use poor quality material and outdated designs, meaning users need to exert more effort to get usable light. And lastly, poor economy and durability. Current designs are often uncomfortable to use and can't handle harsh conditions, making them unreliable for long-term or rugged use. For the related works and alternative method, while technologies like hand crank radios and solar-powered lamps exist, they each have their limitations. Solar lamp, for example, depend heavily on sunlight. Dynamo lamp stands out because they work independently on environmental factors. That said, their designs and performance still have significant room for improvement. For the theoretical foundations, at the heart of the dynamo lamp is the Faraday law of electromagnetic induction. It states that an electromagnetic force EMF is induced in a conductor when it experiences a changing magnetic flux. This is the core physics that allow mechanical cranking to generate electricity. For weakness and opportunity for enhancement, many current lamps use low crack magnets and backseat coil design, making them inefficient. Also, EMI shielding is often completely neglected. Here's what we propose to address this problem. First, use highly efficiency magnetic material to improve energy conversion. Secondly, introduce Faraday cage or MU metal shielding to control EMI. And lastly, redesign the lamp for economic use and rugged durability in outdoor or emergency setting. For the literature review, research by Griffiths shows that a better coil design can significantly enhance energy harvesting. EMI studies also offer promising shielding techniques, but here's the issues. These innovations are rarely applied in small, portable dynamo lamps, and that the gap over the end profile. The expected benefit by improving energy efficiency, reducing EMI, and enhancing durability, this project will make dynamo lamps more reliable for emergency use, more convenient for outdoor adventure, more practical for regions with limited electricity, all while supporting a sustainable off-grid energy production. Thank you for your attention, and that's all for me. Thank you.
So now I will be going to continue our presentation by presenting the objective of our project proposal. So there are 4 objectives in total. Firstly being to investigate the dynamo lamp as an application of time varying field. Secondly is to analyze the underlying electromagnetic principles that includes Faraday law and Lenz's law. And thirdly is to propose an enhanced dynamo lamp design that address EMI, which is electromagnetic interference, efficiency and ergonomics. And lastly is to develop a prototype that incorporates the advanced materials and shielding mechanism to further improve the functionality of the dynamo lamp. So that is it for the objective. Now I will be going to pass the presentation to my friend.
Assalamualaikum and hi, my name is Wan Afif Amjad bin Wan Suhairi and my metric number is DE2208187, and right now I will continue our group presentation video about our project with the next part, which is the project details and description. So this one is going to be methodology. So first we did a literature review, which is this means we studied the existing dynamo lamp designs and learned about electromagnetic theory and its applications. Next, we use software like Tinkercad to simulate and model the design. Then we will build a prototype of a dynamo lamp with high efficient magnets with an EMI shielding. After that, we tested in control environments, measuring like output, energy conversion efficiency and EMI levels. And finally, we optimize the design based on the test results to improve ergonomics and durability. So now let us talk about the design of the dynamo lamp. So the key parts include a coil winding, which is a spiral coil that generates an electromotive force through electromagnetic induction as the magnet moves. There is also a permanent magnet, a gray cylinder in the center that creates a changing magnetic flux when you move it. The LED at the front, the yellow dome, turns electrical energy into light, and the housing, a durable black casing, protects the internal parts and makes the lamp portable. And here is a 3D design to show how it looks. So basically this project connects to what we have learned in our class. We use concepts like Faraday's law, Lenz's law, and time varying fields. The dynamo generates electromagnetic field from changing magnetic flux and converts it to DC, just like we studied in class. Next part is the theoretical work. Finally, let's look at the theoretical side. We use Faraday's law, which is epsilon equal to minus d phi b over dt, where phi b is the magnetic flux. Lenz's law says the induced current opposes the change in flux, adding some resistance. We also calculated energy conversion efficiency using eta equal to P out over P in, where P in is the mechanical input. To make it better, we use finite element method tools to model field distributions and optimize the coil geometry. Thank you, that's all from me.
So to wrap up our presentation, I will conclude the presentation by saying that the Dynamo lamp project showcased the real-world use of time-varying field that apply both Faraday's law and Lenz's law to generate light from motion. So, by further improving the efficiency, reducing the electromagnetic interference, and enhancing the design, the lamp become more practical and reliable in real-life usage. This project not only provides a sustainable lighting solution, but it also helps strengthen the understanding and use of electromagnetic principle in everyday technology. So that is all from us. Thank you.